So for 20 we have, determine the oxidation number of chlorine in each of these chlorine oxides. So A, B, C, D, E, and we want the oxidation number of chlorine. So A, Cl2O, B, Cl2O3, C, Cl2O3, D, Cl2O, and E, Cl2O5. Okay, so with this being said, the good news is that we all have oxygen there, each of them. And oxygen, the rule is that the oxidation number for oxygen is -2 unless we're dealing with H2O2, which thankfully for us, none of these are. If this is H2O2, it'd be -1 instead of -2. That's the difference there. But nonetheless, all of these are going to be -2. So let's start with Cl2O. I like to write it out a little bit bigger because I like to assign numbers under it. So oxygen is -2. So above it, because there's only one oxygen, we have -2. And for now, the chlorine, to balance out the oxygen to where we end up with a neutral atom or neutral molecule, we need a +2. And if that was the case, we need each chlorine to be +1. That's how I could use the, I guess, the box method. I go like that. Okay? So with that being said, the first chlorine is +1. Next one, Cl2O3. Same thing, -2, but this time there's 6 of them, so that's -6. So this chlorine side needs to be +6, and that means we have a +6 chlorine. Now for the next one, we have Cl2O3. So similar, we're going to start with the -2 at the bottom, and that means we need -6. So for it to cancel out, we still need a +6, but now there's 2 chlorines, which is how they now distributed between these two, and we get +3. And now Cl2O2. Okay, so now for this one, we have -2 again. That's -4 total. So chlorine needs to be +4. That's the amount they needed on that side. And now for the last one, Cl2O5. Same thing. We have Cl2O5, -2, and that means this would be -10. So this needs to be +10, and that means this has to be +5 for each chlorine. So we have quite a big range of different numbers. Let's see how we did based on our colleague. So they just state the oxidation rules. I just wanted to focus on the one oxidation rule that talks about oxygen. And where is that? The oxidation number of oxygen is -2. Okay, that is what we want. Okay, so that is how we get +1 in the Cl2O. Perfect. In the Cl2O3, we get +6, so that is perfect. The Cl2O3, as they call it, dichlorine trioxide, we get +3. Good so far. In chlorine dioxide, we get +4. So far so good. And for the last one, dichlorine pentoxide, hopefully we get +5, and indeed we do, +5. So with that being said, all of this is correct. So now we finished question 20. We're going to hop into